So what we're looking at doing, what we're concerned about today, is the unit circles and the triangles. And if we had a whole lot of time, I would tell you all the great things that you can do with this. All right. But if you're a roofer, you need to know trigonometry so you can know the angle of the roof and how long the beams need to be, how high it's going to be. When they're doing surveying and they're figuring out land, they don't go and actually walk everything out. They just walk out one distance and then they measure the angle and then they're able to find the area of a whole triangle. When they're dealing with figuring out your cell phones and what frequency they have to use, they use sines and cosines and tangents in order to adjust the frequency signal and stuff like that. So all of that, in fact, anything with electricity, three-phase, graphing, with all of it is triangles. It's all right triangles and it's all trig. Okay, so this is kind of like the ground floor on some of this stuff. I think y'all dealt with some like questions last week with like if you just have like an angle and a height, that you could figure out how high something was. Or did y'all do those problems?
Yes.
Did you have something like that? Maybe application? I don't know. I get a lot of the classes all mixed up. But needless to say, there's a lot of applications for trigonometry. And the more you know about trigonometry, then just sort of like, it's like anything with knowledge, just opens up lots of other avenues. So what we're looking at today is this unit circle up here in the top right, as well as something called the circular function definitions, which are there over on the left-hand side. Okay? So, I really need a cameraman. Anybody in multimedia?
I was for 2 years.
You want to come in? You can sit right here and just adjust it. Bring your stuff, adjust it as needed. That'd be great. Okay. So, right now, when I say sine, cosine, and tangent, what shape do you normally think of? Yeah, specifically a right triangle. And your sort of knowledge and experience looks like this. Right triangle, this angle, theta. When I say, what's the sine of theta? You don't need to write this down here. This is the stuff that you know. You think of what over what?
Opposite over hypotenuse.
Yeah, you think opposite over hypotenuse. The O over the A. Cosine of theta, you're thinking adjacent over hypotenuse. And we can, I put A on the line. And we could go on down to the list. Tangent, secant, cosecant, so on and so forth. What this lesson is about expanding your ideas of what sine, cosine, and tangent are. Okay? We're not going to be confined here to just triangles. All right, now this is something you can't write down. So we'll pick the first quadrant since that's everyone's favorite quadrant. I guess I could make a right triangle here in the first quadrant. First quadrant is actually pretty easy. I've got theta right there. If you think about what we've been calling the adjacent side in terms of this coordinate right here, this point up here has an x and a y coordinate. That x coordinate, however far you've kicked out this way, you've kicked out that adjacent amount. Does that make sense? So like adjacent, and the vertical amount that you've risen up here, that y value is the opposite value. Everybody with me so far? So like we're starting to rethink about adjacent and opposites in terms of x's and y's. Okay? And instead of hypotenuse, okay, we're going to think of like this point right here is on a circle. All right? And this would be from the center to the edge. That's the what, folks?
hypotenuse?
Yeah, but with in context of a circle.
Oh, arc.
Yeah, the radius. Okay. So, like I said, we're sort of thinking this in sort of different ways. Now, this circle over here that's drawn for you is called the unit circle, although I like to call it the 1 unit circle, because it has a radius of 1. What's interesting is that you can have angles that are bigger or smaller than just like what fits inside one little triangle. For instance, I could have an angle that ends right up here. Now notice it's still part of that circle, so what's its radius? 1. Okay? And so we're rotating all the way along there. But this coordinate, it's still going to have an x value and a y value. And we can think about that as having, you know, in terms of this smaller angle right here, it still has an adjacent and an opposite side. Okay? And as it turns out, there's a lot of similarities between all the angles that are here in the first quadrant and all the angles over there in that quadrant. For instance, I kind of tried to make this look kind of to scale. What do you notice about this y value and this y value? Yeah, they're the same. And if you kind of eyeball it just right, you can see that the amount that this is kicked out over this way is the same amount that that's kicked out that way. So there's a lot of parallelism here. If we were to then reflect this down to the third quadrant, you don't need to write that, but you end up with everything's just negative. It's just negative x and then negative y. And if we kick this down over here, flip it across, you have the positive x, but the y value is now negative. Okay? So what we're concerned with now is, like I said, expanding your idea of sine, cosine, and tangent, okay? So that sine is no longer just opposite over hypotenuse, okay? Instead, now sine is equal to, think about what it would correspond to in this first quadrant. What are we calling the opposite here? The y value. And what are we calling the hypotenuse? The radius, the r. So sine is now y over r. Okay? That's sort of like a more generic way of describing sine. Okay? We're not, now, you're like, what about with triangles? Yeah, if it's a triangle, then yeah, it's still opposite, adjacent, hypotenuse, whatever. But what this allows us to do, I should have put sine of theta, sorry about that. Sine of theta equals. If we have this as our definition of sine, then we now can, as the y value over the r value, we can now take the sine of angles that are bigger than 90. Okay? Notice, when we've got sine, cosine, and we're limited inside a triangle, this angle right here can't be any bigger than 90. Because otherwise you'd have like 100 plus 90 is 190 degrees. That's not going to work. Every triangle, all angles have to add up to equal 180, right? So this sucker has to be less than 90. And that locks you in to only dealing with stuff here in the first quadrant. If we change the rules, if, expand our minds here to recasting sine as y over r, then we can deal with angles like this weird one right here. There's no way I can have a right triangle. I mean, good grief. Can you make a right triangle that looks like this? There's one angle. Here's the right angle. Now connect the dots. There's no way, right? There's no way I can extend this forever and extend it. They'll never meet, okay? So But if I say it's the y over the r, boom, I can figure it out. So cosine is now going to be described as x over r. Yep. You can write that one down. Tangent, it was opposite over adjacent. Let's now call it, what's opposite? Catch it? Y. Adjacent
X
is your x. All right. In fact, if you look on that chart, this is what are called the circular function definitions. They're already written there on that chart, right? Just for completeness sake, I'll write them. Cosecant, as you know from above, that's the reciprocal of sine. It's just you flip it, okay? So cosecant is r over y. Secant is the reciprocal of cosine, so that's r over x. And cotangent is the reciprocal of tangent, that's x over y. And you're like, okay, I get it, I see the formulas. Now let's do some problems. So if I said, what is the sine of pi over 6? Would you rather me say 30 degrees? I'll say 30 degrees. What's the sine of 30 degrees? Well, it's going to be the y over the r value, right? Like, okay, do I need to go out and create a triangle with a 30-degree angle? No, you've got it right there. If you look over there, at the 30 degrees with 1 on the hypotenuse, what is the coordinate of that point?
Square root 3 over 2.
Comma.
1 over 2.
All right. Now what they've actually told you is that if you have a 30-degree angle, the x value, root 3 over 2.
There's a phone charging right there.
That's not my alarm. My rocket alarm. Go. You know,
Maybe if you just turn it off, like the power.
I wonder if it's hers. Find my iPhone alert. We found it.
They're gonna keep doing that until I find it.
Can we just turn it off, right? Should we take a picture?
Take multiple.
Well, unless it's Miss Barnes, that would not be very
Yeah,
nice.
I feel like she would have left it on her desk.
Well, the problem is if I turn it off, then they're not going to be able to find it.
Put it on the hallway.
They'll remember. We'll plug it in those. Alright, scratch that from the video. No, just kidding. They've told us, back to our problem here, with that information right there, root 3 over 2 comma 1/2, that, and that's right, isn't it? That's at the x and y value? I'm gonna double check, yeah, okay, you're right. That the x value right there is root 3 over 2, and the y value right here is 1/2. They've already gone to the trouble of actually measuring it, creating it, and doing all that stuff. They've got the x value right here, they've got the y value right here, we've got the r value right here, we've got everything we need. We're just going to say the y value, which is 1/2, the r value, which is 1. Now, pre-cal students, do you know what 1/2 divided by 1 is without a calculator?
1/4.
Okay, play a game. What's 5 divided by 1?
5.
6 divided by 1.
6.
1/2 divided by 1.
1/2.
1/2. Yeah. Okay. So it's 1/2. Have you done problems like this before? Was this last week? Is this brand new for you? Brand new. Okay, great. There you go, that's the answer to the question, 1/2. Sine of 30, 1/2, done. It's exact, it's great. What if I had said cosine of 30? Do you have calculators? Some of you do.
The distances.
What the R is?
Yeah.
Yeah, I do. It's the 1 unit circle.
Also just one?
It's always 1 for the R. Yeah, let's go ahead and hand a few of those out there. We don't need everybody. Thank you, Megan. It's always 1. It's called the 1 unit circle. So you're locked in at 1. You know that. All right, cosine. Looking at the trig chart, and AJ, feel free to grab that back if you need it. If you need the trig chart. Somebody call out to me. What's the ratio for cosine of 30 or cosine? What over what? I'm hearing x over r. I agree. So, no need for a calculator. So let's put those up. Just kidding.
Are you kidding me?
No, but there's no need for a calculator on these. The trig chart is more powerful than that calculator when it comes to this. What's the x value? This means look at the x value on that 30 degrees.
Square root of 3 over 2.
Root 3 over 2.
Over 1.
Over 1. Pre-cal students, can you figure out what square root of 3 over 2 is?
Square root of 3 over 2.
Root 3 over 2. Okay, there you go. Good job. Now, grab your calculator, and I'll show you why your calculator is deficient in this area. Make sure that it's in degree mode, and type in that same problem that we just did, cosine 30, enter. What do y'all get? Benjay, what do you get?
I got like the decimal one.
Yeah, call out the decimal here to us.
0.87.
Okay, 27, is it 0.8660 something?
Yeah.
Okay. Yeah. All right. Oh, wait. I know. I've been a math student for a while. I'm going to do math enter, enter. Anybody tried that?
Yeah,
Yeah.
it'll work.
It doesn't work. Right. Math enter, enter doesn't work with irrational numbers. It only works with rational numbers that it can turn into a ratio of whole number over whole number. Okay? So, square root of 3 over 2 is actually irrational. It never repeats, and it never ends. And your calculator can never give you the exact answer like the unit circle can. Okay? And guess what answer they're going to be wanting on your homework?
That one.
Root 3 over 2. They're not looking for 0.866 or 8660, whatever the next digits are. Okay? So, that's why you have to use unit circle on these. Let's try a tangent problem. Tangent of 30 degrees. That's the, call it out to me again. Y over x. So I'm just going to go up here and look at the unit circle. The y value is
1/2.
I'm going to make that tiny fraction in the numerator over
3 squared over 2.
Yep. Square root of 3 over 2. Fraction of fractions. Fractionception. So, going back to the well here. 6th grade math. Yeah, he's got it. I see the thing. Right? Does anybody remember how you took 1/2 divided by like 3/4?
Flip the second one.
Flip the second one. Yeah, that's right. Reciprocal. So you do 1/2 times the reciprocal of the others. That's a thing. All right? So that's what we're going to do over here. We're going to say, keep the numerator as is, 1/2. But then instead of saying divided by root 3 over 2, we're going to say times, and then flip it.
2 square root
2 over square roots of 3. Now, if you are also familiar with your fraction math, you'll know that if everything up here is being multiplied and everything down here is being multiplied, then some things would cancel. 2 divided by 2 is 1. So I just have a 1 here, so 1 times 1, so 1 divided by square root of 3. Now, Mr. York may have told you that the basement is not for partying. There's no radical parties down there in the basement. Have y'all heard? No radicals downstairs? Yeah, okay, so no, you got a party upstairs. So this, although it is correct and in a great form, as mathematicians, we generally do not like square roots down there in the denominator. So we need to change what it looks like. This process is called rationalizing the denominator. Have y'all done that before? Does it sound familiar?
Yes.
Multiply the top and bottom by square root of it.
That is correct. I'm doing it in a different color so that you understand that this is me inserting it into the problem if you're a color person. That is, if you like different colors. All right, now, pre-cal students, why is this is an algebra 2, because algebra 2 I just say do it. You're pre-cal, so we understand why we're doing it. Do you know what any number divided by itself is?
1.
You've answered it up. Yeah, okay, sure. Yeah, 1. 5 over 5 is 1. 6 over 6 is 1. Any number over itself is 1. So root 3 over root 3 is 1. Follow-up question. Do you know what anything times 1 is? Itself. It's the same thing. 5 times 1 is 5. 6 times 1 is 6. Okay? So, am I really changing the value of the green number right there?
No.
I'm not changing its value. I am changing what it looks like, though. Sort of like if you put on some different clothes. Okay? You're still you. All right? Clothes do not make the man. All right. You joke, you laugh, 7th period. All right? All right. 1 times root 3 is root 3. Root 3 times root 3, another property of math. Good grief, this is why everybody gets hung up on this stuff, because there's so many different math properties that you have to know in order to do this stuff. If you have a square root times a square root, you can multiply them together. I'm just going to put 9 right there, because it is easier to write. So root 3 times root 3 is the square root of 9. Simplify time. Can we simplify the square root of 3? Does it break down into any other smaller numbers?
No.
No. There's no whole number that multiplied by itself equals 3. Is there a whole number that multiplied by itself equals 9?
Yes.
That is?
3.
That is your final answer. Root 3 over 3. A lot of work there. Alright, but I don't like doing more work than necessary. So I will periodically check my answer. Ladies, go ahead and type in square root of 3, make sure you close your parentheses, divided by 3, and give me a decimal approximation, 3 digits after the decimal, please. Ladies, guys, you're going to just type in tangent 30. 3 digits after the decimal. And everybody's going to say their answer on 3. 1, 2, 3.
0.577350269.
I'm not hearing you, ladies. Are you getting what they're saying? Guys, say it one more time.
0.577350269.
Ladies, what'd you get? I want to hear those high-pitched voices. Go ahead. There we go. Okay, so did y'all get, ladies, did y'all get 0.5773?
Yes.
Don't just be accommodating. You did? Okay, good. All right. So you want to say, how do I check my work to make sure I got it right on the quiz or on my homework without having to do all this nonsense 2 times? This is how you check it. You take your final answer and you figure out what the decimal equivalent is, and you go back to the original thing and you just type that in, and if they match, then every step you've done along the way is allowed. Okay? And we can fully say this equals this equals this equals this equals this equals this equals this. That's what math is. Turning one things into another so that they look good. Okay.
Reformatting.
Yeah. I chose some harder examples that follow. Here we go. But by now this is fast. at this point, it's just a matter of doing like 5 or 6 more so that you get it and you know you got it. So here we go. Cosecant of 3 pi over 4. So, first step from the formula, what is cosecant equal to?
Y over
I think it's r over y.
R.
Actually.
Over Y.
Okay, that's from the formula. Okay, now look at the unit circle. Where's 3 pi over 4?
To the left, it's more of an obtuse.
Second quadrant, got it, right there. So that's at an angle of 3 pi over 4. Somebody else, what are the coordinates there? At 3 pi over 4.
Negative square root over 2. And
So you said negative root 2 over 2?
Yeah.
Yeah, you can say root, that's fine. Keep going.
And then
It-
root 2 over 2.
Got it. So if you need to, you can always label that's the x, that's the y, and 1 is the r value. And you don't even need to write that even if you can read it. I mean, if you just know this stuff. R, so now I'm going to plug it in. R is 1. Y,
Square root 2 over 2.
yep. Alright, if you can beat me, do it. Fraction math. If it helps, always draw a really, really big, thick bar there and keep your work nice and neat. Otherwise, you'll forget where the fraction is. But this is the numerator and this is the denominator. So, fraction math, numerator, do a little flip thing, right? So keep that the same, times, and we flip this, 2 over root 2. So that's going to equal 1 times anything is itself, so we've got 2 over root 2. Are we satisfied? What do you want to do, Lucas?
Multiply the radical.
Yep. We want to multiply that sucker by what?
Itself. Or the two radical over root 2 radical.
Yep.
By itself.
Hey, I will say root 2 over root 2. You are correct. Radical 2 over radical 2. So let's keep this going here. 2 times root 2 is 2 times root 2. Now you might be like, oh, we can cancel. Yeah, you can cancel, but then you're going to get rid of this whole point. Get rid of this, you can cancel that thing right there.
And it's just an infinite loop.
Right, exactly. And so you're never going to get anywhere. We want to multiply these suckers so that we can get rid of that square root down there. Now the square root of 2 times square root of 2 is the square root of 2 times 2, or the square root of 4. If you've forgotten that, just remember the property. Square root of a times the square root of b equals the square root of a times b. Can the square root of 2 be simplified?
No.
No. So 2 root 2 stays. Square root of 4. 2. Now we can talk about simplifying. Notice everything up here is being multiplied, everything down here, that means you could split it up, and that's a whole other discussion. But 2 over 2 is going to reduce to a 1 and a 1 here, so 1 times root 2 over 1. So we end up with
Square root 2.
square root 2. Alright guys, you get the hard part now. Square root of 2 is
1.41421356.
okay. And so ladies, oh wait, do you have the cosecant button on your calculator? No, you don't. Instead, if you want to check this one, you're going to have to do 1 divided by, a cosecant is 1 over, do y'all know those reciprocals? I don't know if you know the reciprocals yet. Each one of these are the reciprocal of the other guy. Cosecant is 1 over sine.
Oh.
But notice, I'm changing it up on you, keeping you on your toes. That's 3 pi over 4. So you're going to have to change your calculator to radian mode and then type in 1 divided by sine 3 pi over 4, enter. And ladies, I await your response. I beat you to it, then the guys get extra credit points.
The same.
1 divided by sine. Stop me. What is it, ladies?
The same thing.
Oh, the same. I thought you were having a side conversation. Okay. Yeah, 1.414. Sorry, guys. No
It's
extra
fine.
points. Okay, let's keep going. Find something really difficult. All right, cotangent 3 pi over 4. Do y'all want to try this all on your own? Cotangent of that same angle. Cotangent 3 pi over 4. Give it a shot. Check your x value. Okay, yeah. Sometimes horizontal fraction bars make it a little bit easier, but you're fine in that case. Take the derivative of that. Pretty good. Start. On track. All right. For the sake of time here, cotangent is what, class? No, not the final answer. Just the x over
y.
x over y is what I'm looking for. Yeah, x over y. We're gonna go speed problem on this one. So you have to find that same angle. It's exactly where we were looking before. So call it out to me. What's the x value?
Negative square root 2 over 2.
Keep going.
Root 2 over 2.
Okay. So same thing as before. Keep the numerator. Negative root 2 over 2 times, flip it, the denominator. 2 over square root 2. Okay. That's nice because 2 in the denominator, 2 in the numerator, those cancel. 2 divided by 2 is 1. In fact, root 2 over root 2 is also 1. So it's like 1, 1, 1, 1, but there's a negative out front, so it's negative 1 for your final answer.
Negative 1.
That's one that you probably could check on your calculator really easily, right? I mean, if you typed in 1 divided by cotangent of 3 pi over 4, or sorry, 1 over tangent, you should also get negative 1. And you're like, hey, why did I just do that in the first place? And the answer is, well, because sometimes you're going to get that root 3 over 2 stuff, and sometimes you're going to get the root 2 over 2, and sometimes you're going to get root 3 over 3. And you don't necessarily know that until you do the problem. Though I guess if you wanted to gamble a little bit, and you're not really pressed for time, you could always just try to do it with the calculator first and see if you get a nice easy answer, like 1/2 or negative 1/2, and then you're like, okay, it's good, I got it. And if you get something like 0.866 or 0.30357, you know, something weird like that, then you just go do it the long way.
Basically anything with a decimal.
What's that?
Basically anything that's not a whole number.
Yeah, well, 1/2 is a possibility. The only other thing that they could do to you is on the last few problems, we give you angles that aren't on the unit circle. Just, you know, for fun. Like,
So fun.
I know, it's a lot of fun. To teach you how to do something and then give you something that doesn't relate to that. Like, for instance, we could give you 3, 5 pi over 2. Hey, don't, we're not done yet. I gotta give you the hard problem.
We're not in here?
All right, no, we're not done yet. Okay, I'll give you, okay. I could say, for instance, the tangent of 390 degrees.
Oh, whoa.
Like, there's no way that's formula. Okay, where is 390 degrees on that unit circle?
It's like, at the 30.
Oh, she says, yeah, she said it's at the 30. Would you agree with that? Isn't 30 degrees the same thing as 390 degrees?
Yes.
Aren't they co-terminal?
Yes.
Mm-hmm. Yeah. So
That's
tangent
+6.
of 390 degrees is the same thing as the tangent of 30 degrees. Yeah. So remember, you always just subtract 360 or add 360 to get to what you're looking for. So like, if we were looking at like the cosine of negative 45 degrees, okay, you could probably figure out where negative 45 degrees is, but if you weren't sure, just add 360 to it. It's going to end up at the same spot. Sum with the calculator. What is negative 45 plus 360?
315.
315. So this is the same thing as the cosine of 315. They both end at the same spot. Okay? So on the last few problems on your homework, it's going to give you sine, cosine, tangent, secant, cosecant, cotangent, only these angles aren't going to be on your unit circle. You're going to have to do one extra preliminary step to get it between 0 and 360, or to get it between 0 and 2 pi. Okay? And that should be very simple. So like, for instance, if it said cosine of negative 3 pi over 4, what would you do to get the equivalent angle? You can't add 360. You could convert it, sure, yeah, you could convert that to degrees. Or, do you remember what number it is that goes all the way around in radians?
360?
In degrees. In radian, por favor.
12 pi over 6.
Close, it's 2 pi.
2 pi.
Alright? That's how you solve those coterminal questions on the quiz.
The famous math record.
Yes. Okay, so today we talked about how to use the unit circle and those circular functions over there, new ways to find sine, cosine, and tangent. Alright? Just plug it in, look at the x and y or the r value is 1, and then do your fraction math to get to the right answer. Okay? See you next time.
Bye.
Thanks for watching.
Bye.
Goodbye.